Hello, my name is Daniel, and today we'll be going through the AMC 12A from the year 2012, so let's get started. First problem, a bug crosses along a number line starting at -2, it crosses to -6, then turns around and crosses to 5. How many units does the bug crawl altogether? Okay, so it starts at -2, and then it goes to -6, and then it comes around to to +5. So this is 4, and this is 11. That gives us 15 units. The answer is E. Number 2, Candy can frost a cupcake every 20 seconds, and Lacey can frost a cupcake every 30 seconds. Working together, how many cupcakes can they frost in 5 minutes? Okay, so Candy can frost 3 per minute, because it's 1 per every 20 seconds, and Lacey can do 2 per minute, so together they can do 5 per minute. 5 per minute, but they have 5 minutes to do it, so that means they have 25 per minute. So this will be our answer, it's D. Number 3, a box 2 centimeters high, 3 centimeters wide, and 5 centimeters long can hold 40 grams of clay. A second box with twice the height, 3 times the width, and the same length as the first box can hold n grams of clay. What is n? Okay, so since the first one can hold 40 grams of clay, but then the second box, it has twice the height, so times 2, and then 3 times the width, times 3, and this will be our new volume. So this is going to be 40 times 6, which is 240. So this is the answer, it's D. Number 4, in a bag of marbles, 3 over 5 of the marbles are blue and the rest are red. Okay, so that means if we have 5, then we have 3 blue and 2 red. If the number of red marbles is doubled and the number of blue marbles stays the same, what fraction of the marbles will be red? Okay, so since this is doubled, that means we have 4. So out of 7, 4 will be red. So that is 4 over 7. And that's the answer, it's C. Number 5, a fruit salad consists of blueberries, raspberries, grapes, and cherries. So let's say that's B, R, G, and C for cherries. Right? The fruit salad has a total of 280 pieces of fruit. There are twice as many raspberries as blueberries, 3 times as many grapes as cherries, and 4 times as many cherries as raspberries. How many cherries are there in the fruit salad? Okay, so since there's twice as many raspberries as blueberries, then if B is 1, then raspberry is 2. And since there are 4 times as many cherries as raspberries there, that means there are 8 cherries. And since there's 3 times as many grapes as cherries, that means there's 24 grapes. And adding this all together, we get a sum of 35, but it said that it has a total of 280, so total has to be 280. That means we have to multiply 8. And so we have to multiply 8 to everything here to get the actual number, and we want how many cherries, so for that we will have to multiply 8 to that, right? 8 times 8 equals 64. So 64 is the answer, it's D. Number 6, the sums of 3 whole numbers taken in pairs are 12, 17, and 19. What is the middle number? Okay, so if we say that our 3 numbers are A, B, and C, that means A plus B is 12, B plus C is 17, and C plus A is 19. The order doesn't really matter because it's all just going to have the same thing. So if we add them all up, right, then that's going to give us 2A plus 2B plus 2C equals 48. And dividing by 2, we get A plus B plus C equals 24. And comparing these 3 to this one, we can get each of the A, B, C values. So from this one, we can get that C equals 12. And from this, we can get that A equals 7. And from this and this, we can get that B equals 5. So our numbers are 5, 7, and 12. And our middle number is 7. So that's the answer. It's D. Number 7, Mary divides a circle into 12 sectors. The central angles of the sectors measured in degrees are all integers and they form an arithmetic sequence. What is the degree measure of the smallest possible sector angle? Okay, so you can see that the angles are A plus B, A plus 2B, A plus 3B, all the way up to A plus 11B, because it said that there's 12 sectors. So this much is 11 and this is the last 12th one. So this much is all 12 sectors, and if we add them all up, this is 12A plus 66B equals 360, and so dividing by 6, we get that 2A plus 11B equals 60. But then since we want the smallest possible sector angle, that means we want the smallest possible A, and so for the smallest possible A, that means we want the largest possible B. And so out of here, the largest B that we can get while making 2 an even number is for B to be equal to 4. So if B is 4, that means 2A equals 16 minus 44, which is 16. That means A is 16 over 2, which is 8. So 8 is our answer. It's C. Number 8, an iterative average of the numbers 1, 2, 3, 4, and 5 is computed in the following way. Arrange the 5 numbers in some order, find the mean of the first 2 numbers, then find the mean of that with the third number, then the mean of that with the fourth number, and finally the mean of that with the fifth number. What is the difference between the largest and smallest possible values that can be obtained using the procedure? Okay, so if we say that we have numbers A, B, C, D, and E, and this is 1, 2, 3, 4, and 5 in some random order, then the iterative average would be First of all, we have a plus b over 2, and then plus c over 2, plus d over 2, plus e over 2. And so this is going to be a plus b all over 16, plus c over 8, plus d over 4, plus e over 2. So that means to get our largest values, so that means e should be the biggest and a and b should be the smallest. Largest, that would be if a and b is 1, 2, 3, 4, and 5 in this order. That would be, if we do all of that, that would be all over 16, and it would be 3 plus, and then 3 times 2 is 6, plus 16 plus 40, which is going to be equal to 65 over 16. And so the largest is going to be 65 over 16. And now we can do the smallest. That will be if a plus b are the biggest and e is the smallest. So that would be, let's say, then that would mean it's 5, 4, 3, 2, 1, like that. And so that would give us all over 16, and then 9 plus 6 plus 8, right? 8 plus 8. So this is going to be 31 over 16. And so comparing those two, we have to get their difference. So it's 65 over 16 minus 31 over 16. So this is going to be 34 over 16, and so this is going to be 17 over 8. So 17 over 8, that's the answer, it's C. Number 9, a year is a leap year if and only if the year number is divisible by 400, such as 2000, or is divisible by 4 but not by 100, such as 2012. The 200th anniversary of the birth of novelist Charles Dickens was celebrated on February 7, 2012, a Tuesday. On what day of the week was Dickens born? Okay, so first of all, we have to know that since 365 divided by 7 has remainder 1, so that means every year days are pushed forward 1 day. So days are pushed forward 1 day every year. And so if this is the 200th anniversary, then that means we have 200 more days. But then we have to account for leap years also. And 200, that divided by 4. 200 divided by 4, this is 50, and we have to subtract 1. Because we know that 1900, this is divisible by 4 and 100, but not by 400. So that means 1900, this is not a leap year. So although it's divisible by 4, it's not a leap year, so we have to get that out. That's why we have this minus 1 here. So this is going to equal 49. And so we have to add 49 more days. 49 days. Like that. And so we have this much added to the original day is a Tuesday. So we have to go back 249 days from Tuesday. So if we do that, that means we have to do Tuesday minus 200 days minus 49 days. And this is going to be equal to minus 200 days. So Tuesday minus 200 days, because that's a multiple of 7. And 200, we know that 196, that's also a multiple of 7, because that's 14 squared. So if we take away 196, that's going to be just minus 4 days. On what day of the week was Dickens born? This gives us Tuesdays minus 4 days. So this is Tuesday minus 4 days, and that would be a Friday. So Friday is our answer, it's A. Number 10, a triangle has area 30, one side length 10, and the median to that of side length 9. Let theta be the acute angle formed by that side and the median. What is sine theta? Okay, so if we bring out a diagram here, then it would look something like this. So this area would be 30, and this side would be length 10, and the median to this side, so that much would be length 9. And we know that this is theta, and we want sine of theta. Okay, so since this is a median, right, so since this is a median, that means these two lengths are the same. So that means the area is split in half, and this length is 5. So that means we know, the area of this triangle, and that's 15, because that's 30 divided by 2. And so the area is 15, but we know that the area is also 1/2 AB sine theta, where A and B are these lengths, and theta is this, and theta is that angle. And so we know the A and B, so we can get sine theta. So 15 equals 1/2 times 9 times 5 sine theta. So therefore, sine theta equals 9 times 5 over 15 times 2 over 9 times 5. And that is going to be equal to 30 over 45, which is 2 over 3. So this is the answer. It's D. Number 11, Alex, Mel, and Chelsea play a game that has 6 rounds. In each round, there is a single winner, and the outcomes of the rounds are independent. For each round, the probability that Alex wins is 1/2, and Mel is twice as likely to win as Chelsea. What is the probability that Alex wins 3 rounds, Mel wins 2 rounds, and Chelsea wins 1 round? Okay, so we have Alex, Mel, and Chelsea. And Alex winning probability, that's 1/2, and these two summed, that would be also 1/2. But then since Mel is twice as likely to win as Chelsea, That means Mel's probability of winning is 1 over 3, and Chelsea's probability of winning is 1 over 6. With this in mind, the probability that Alex wins 3 rounds, that's 6 choose 3, so 6 out of the 3 Alex wins. Mel wins 2 rounds, so times 3 choose 2, and then Chelsea wins 1 round, that's just 1 choose 1, so I'll just not do that. And then multiply by 1/2 to the third power, 1/2 to the third power, because he won 3 times, and the Mel 1/3 to the second power, times 1 over 6 to the first power. This is going to be, this is basically, 60 times 1 over 8 times 1 over 9 times 1 over 6. So this is going to be equal to 10 over 72, which is 5 over 36. So this is our answer, it's B. Number 12, a square region ABCD is externally tangent to the circle with equation x squared plus y squared equals 1 at the point 0, 1 on the side CD. Vertices A and B are on the circle with equation x squared plus y squared equals 4. What is the side length of this square? Okay, so if we put out a diagram here, then this is going to be what that looks like. And so here we are going to have this big circle, and this is ABCD. And here, this would be A, this would be B, this would be C, and this would be D. And this circle, that one has a radius of 1. So we can say, that much, that is a radius of 1. And the side CD and this one, that would have a radius of 2, because 4 is 2 squared. And so now we can use these lengths, making a right triangle, right, because we want the area of the square. And so if we do that, then we can put a line from the middle to the midpoint, to the midpoint, and that would go like that in the middle, and we would be right there. And lastly, if we connect this point, we have our right triangle with this as a right angle. This is one side of that's one side of the square. And let's say that this side length is x, and so our full side length would be 2x, and so that means this would be 2x, and this would be 1. And this much, that's the radius of the big circle, so that's 2. So by the Pythagorean theorem, we know that this squared equals this squared plus that squared. So that gives us that 2 squared equals x squared plus 2x plus 1 squared. So 4 equals x squared plus 4x squared plus 4x plus 1. So 5x squared plus 4x minus 3 equals 0. So this gives us that x is equal to all over 5, and then this gives us, if we use the quadratic formula, minus 2 plus or minus root, and then 4 plus 15. 4 plus 15, that is, it has to be positive. Since x has to be positive, it's root 19 minus 2 over 5. The full side length is 2x, right? So 2x, this equals 2 root 19 minus 4 over 5. So this is our answer. It's D. Number 13, Paul the painter and her 2 helpers each paint at a constant but different rates. They always start at 8 a.m. and all 3 always take the same amount of time to eat lunch. On Monday, the 3 of them painted 50% of a house, quitting at 4 p.m. On Tuesday, when Paula wasn't there, the 2 helpers painted only 24% of the house and quit at 2:12 p.m. On Wednesday, Paula worked by herself and finished the house by working until 7:12 p.m. How long in minutes was each day's lunch break? Okay, so let's say that each day's lunch break was T hours. And let's say that Paula's rate of working, this is P, and the helper's rate, this would be H. And so if we set that up, then on Monday, they quit at 4 p.m. and they started at 8 a.m. So they worked 8 hours. So 8 hours minus the lunch break. So that's 8 minus T hours times P plus H, because they both did it together. This is 50%. So let's say that's just 50. And on Tuesday, it's just the helpers, right? So that's 24% of the house and until 2:12 p.m. So that's going to be 6.2 minus T times H equals 24. And lastly, Paula worked by herself on Wednesday, so that's until 7:12 p.m., which is almost 12 hours. That's 11.2 hours. And then minus T, she had the lunch break, obviously, and apparently she didn't have a dinner break, and so let's just say that this is P. So this is going to be 26, and the first thing that we notice is that this is equal to those two added together. So that's going to give us 8 minus T, P plus H equals 6.2 minus T times H plus 11.2 minus T times P. TP and TH, they all cancel. So if we just cancel those, so cancel out the T's, like that, then we will have 8P plus 8H equals 6.2H plus 11.2P. And so this will give us that 1.8h. This is equal to 3.2p. And so taking out the decimals, we see that 9h equals 16p. We now know that 9h equals 16p. So that means Paula to helper, this ratio is equal to 9 to 16. So that's all we need right now. So Paula's rate to helper's rate, that is 9 to 16. And then using this, we will just compare these two, right? So comparing those two, so since this is 50 and this is 24, now we can see that 24 times 8 minus t, p plus h, this is equal to 50 times 6.2 minus th. So p to h is 9 to 16, so if we put those in there, then that's going to give us 24 times 8 minus t times 9 plus 16, that's 25. That's equal to 50 times 6 minus 2.t times 16. And so we can cancel each of those to get 2, and cancel those and those by 8 to get 3 and 2. And so those 2's are going to come together to make a 4. And so we have 3 8 minus t and 6.2 minus t times 4. That gives us 3 times 8 minus t equals 6.2 minus t times 4. So that is 4 times 6.2 minus t. And so 24 minus 3t equals 24.8 minus 4t. So this gives us t equals 0.8 hours. And 0.8 hours, that's equal to 48 minutes. You just multiply 60, and that's our answer. It's D. Number 14, the closed curve in the figure is made up of 9 congruent circular arcs, each of length 2 pi over 3, where each of the centers of the corresponding circles is among the vertices of a regular hexagon of side 2. What is the area enclosed by the curve? Okay, so first thing that we notice is that this is the length of this arc, so that means 3 times that, so that's the whole thing. Yeah, this means the full arc, so that the full circumference. So this is going to be 2 pi, so that means our radius is 1. So this length is 1, and this length is going to be 2. That's going to be 2, and so on, right? Now, we can draw a hexagon like that by connecting the middles like that. And we can see that if we do that also, we can see that they have the same area, and this and this, they have the same area, and also this and this, they have the same area. And so what we can do is we can move this over there, and we can move this over here, and move this over there, right, to create this full hexagon, right? So that full hexagon, but then plus we have this much left over. So we have these 3 parts left over, and they will just sum together to make a full circle. So this just gives us the hexagon, and then we have plus, and then these 3 things, right? That will come together to make a circle. So this and this, those are together. And so this is going to be equal to, since we saw that each side length, that's 2. That means we have 6 of side length 2 equilateral triangles. So 6 times root 3 over 4 times 2 squared. This plus, and then this circle that has a radius of 1. That has a radius of 1, so it's pi times 1 squared. And that is going to be 6 root 3 plus pi. So 6 root 3 plus pi, that's the answer, it's E. Number 15, a 3 by 3 square is partitioned into 9 unit squares. Each unit square is painted either white or black, with each color being equally likely, chosen independently and at random. The square is then rotated 90 degrees clockwise about its center, and every white square in a position formerly occupied by a black square is painted black. The colors of all other squares are left unchanged. What is the probability that the grid is now entirely black? Okay, so we can draw a 3 by 3 square like that, and it's partitioned to 9 unit squares. They are either painted white or black, so this means that our total choices, this is going to be 2 to the 9th power, which is 512. And so this is rotated 90 degrees clockwise. So first of all, we have to notice that this middle part, that just keeps constant however much it is rotated. So that means for the whole thing to be black, then this must be black from the very start. So that must be black. We can look at these 4 squares and these 4 squares separately, because when you rotate this thing 90 degrees, you can see that each orange square jumps to the next orange square, and same for the blue, each jumps to the next blue square. So that basically means the blue ones will only influence blues, the orange ones, these will only influence the oranges. And so now if we just take those blue ones, and let's just make a separate grid like that. This is just made up of just the blue ones. And for this to be all black when it is rotated, then we have seven possibilities. First is that they can all be black. Then when it's rotated, that will still be black. And then the second is if 3 of these are black, then when it's rotated, then this is going to be black also. And so that will just make everything black. But then for that, we have 3 choices. We can make this one blank, we can have this one white and all the other black, or we can have this one white and all the other black, or we can have this one white, or we can have that one white. So we have 4 more. So far we have 4 plus 1. This is for just 3 black, and this is for all black. And lastly, we can have 2 black. So if we have these 2 black and the other white, then if we rotate them, then it's just gonna be all black. And one more way we are going to do that, and so that will also satisfy the choices. So we have 4 plus 1 plus 2 equals 7 choices. So the blues, this has 7 choices, and the oranges, that's also just the same thing. So that's 7 choices. And so now we can say that the total is 512, but then the probability that the grid is entirely black is this times this, because they're independent, so it's 7 times 7. This is going to be equal to 49 over 512, and that's our answer. It's A. Number 16, circle C1 has its center O lying on circle C2. The 2 circles meet at X and Y. Point C in the exterior of C1 lies on circle C2, and XZ equals 13, OZ equals 11, and YZ equals 7. What is the radius of circle C1? Okay, so if we put a diagram here, then we are going to get this. We have this circle is C1, this is C1, and this is C2, and then they meet at X and Y, so this and this points, they are going to be X and Y. Point Z, point Z is going to be right here. This is Z, and XZ is 13, this is O, OZ is 11, and YZ is 7. What is the radius of circle C1? Let's just set those 2 points as just A and B, like that. So now we want the radius of circle C1. First of all, we notice that XO and OY, they have the same length because they are both radii. And so that just means, since those 2 have the same length, that means these 2 are the same angles, right? And since those 2 are the same angles, we can see that OAZ and OZY, they are congruent triangles because these 2 are equal, and this is also there, that's also shared, and so that gives us that YZ and AZ are equal. And so by that we can see that AZ is also 7, but then since the whole thing is 13, that means this much is 6, but then since this is divided into 2, then we get 3 and 3. So that means that XB is going to be 3 and AB is going to be 3. And now we can see that we can look at this triangle ZBO, right? This is B, so that's triangle ZBO. And we can see that that's a right triangle because that's a right angle. And we know that this is that's length 10 because of 3 plus 7. And this is 11, right? Because that's given. So we have a right triangle. And now we can get the length of OB. And so we can write that out. OB, this is going to be equal to the root of 11 squared. So 11 squared minus 7 plus 3, which is 10 squared. So this is going to be root 121 minus 100. This is root 21. So OB is equal to root 21, like that. And now we can finally focus on OBA, this triangle. We know that OB, that has a length of root 21, and we know that this is also a right angle, so we can get the hypotenuse of that triangle, which just happens to be the radius of C1. And so OA, this is going to be root of root 21 squared, that's just 21, plus 3 squared, this is root of 30. And so this is going to be our answer, that is OA. So that's E. Number 17. Let S be a subset of 1, 2, 3 all the way to 30 with the property that no pair of distinct elements in S has a sum divisible by 5. What is the largest possible size of S? Okay, so in this set, we have numbers that have form of 5x or 5x plus 1 form, or that are in 5x plus 2, 5x plus 3, or 5x plus 4. If you see, there are 6 of each because we have all the numbers from 1 to 30. First, we have to notice that only one 5x we can get. Only one 5x is possible, because if we have any more 5x's, then those two are going to just sum to be divisible by 5. So only one is possible. And also, we can't have no 5x plus 1 and 5x plus 4 at the same time. So that means we can only have either one of these. So that means that we can just have 6 of 5x plus 1, and that will be our maximum because we can't have any 5x plus 4, And same thing for these two. No 5x plus 2 and 5x plus 3 at the same time. This is because those two will also just sum to be divisible by 5, as are these ones. And so for that, we can just get 6 of 5x plus 2, because we can't get any 5x plus 3 once we have even one 5x plus 2. And so our maximum is 1 5x, 6 5x plus 1, and 6 5x plus 2. This gives us 13. And so 13 is our answer, it's B. Number 18. Triangle ABC has AB equals 27, BC equals 25, and CA equals 26. Let I denote the intersection of the internal angle bisectors of triangle ABC. What is BI? Okay, so if we bring out our diagram like this, then we are going to have, this is A, this is B, and this is C. So AB is 27, BC is 25, and CA is 26, like that. If this is the internal angle bisectors, those intersection, that means that I is just the incenter. So that means that we can have a circle that has I as the center and is tangent to AB, BC, and CA. And so if we draw that, then that's going to look something like this, right? That's going to look something like this. Let me translate that a little bit, like that, right? And so if we have that, then we are going to have radii like that. This is going to be R, and this is going to be also a radius, and this is also going to be a radius from here to here. So this is going to be 90 degrees, 90 degrees, and 90 degrees, and they are all length R. Now we can see what each of these lengths are, because we know that these two are the same, these two are the same, and these two are the same. And since we know all three angles, we can get that. And so if we do that, we have, this is 12, 12, and 13, 13, and 14, 14. And if you check again, that does hold true. And so now, if we only know R, then we can get what BI is, right? Because we can use the Pythagorean theorem then. And so since we have all the lengths of the triangle, that means we can use Heron's formula. So we can use Heron's formula. And so using this, we have S equals all over 2, and then this plus this plus this. So that's going to be 26 times 3. That's going to be 39. So S is 39, and so we can get our area is root of 39, and then times 39 minus 26, which is 13, and 39 minus 25, which is 14, times 39 minus 27, which is 12. So this is our answer. So this gives us 39, and multiplied by 4 times root 14. But then we can also get the area another way, because we know that those three triangles, they will sum to the whole area. And since this is all perpendicular, we know that this times this to the half, this times half, this times half, that's just all going to be our area. If we do it in that way, then our area is going to be equal to 1/2 R times this plus this plus this, which is 25 plus 26 plus 27. This is going to be 39R. And so since we know that these two are equal, we can also see that this is equal to this, R. So this gives us that R is equal to 2 root 14. Since R is 2 root 14, we can use the Pythagorean theorem to get BI. And if we do that, BI, this is going to be equal to the root of, and then this is 13, so 13 squared, plus this much R, which is 2 root 14. So 2 root 14 squared. This is going to be equal to the root of 169 plus 56. This is root 225, which is 15. And 15 is our answer. It's A. Number 19. Adam, Benin, Chiang, Deshawn, Esther, and Fiona have internet accounts. Some but not all of them are internet friends with each other, and none of them has an internet friend outside this group. Each of them has the same number of internet friends, and how many ways can this happen? Okay, so since that some but not all of them are internet friends, and none of them has an internet friend outside this group, that means each person can have one friend, or 2 friends, or 3 friends, or 4 friends, and not 5 friends, because not all of them are friends. So we only have these 4 ways. And if we have 1 friend, then that is going to be, if we have 6 people, right? This is A, B, C, D, E, and F. First, we will choose 2. First we will choose from the 6 to be friends. So let's say it's these 2. Then we have 4 left. So that means choose 2 from the 4 left. Let's say it's these 2, right? Then this is automatically the 3rd pair, so we don't have to worry about that. But then now we have to divide it by 6. That's because we can choose this first and then this. Or we can choose like this first and then this, and it will be the same people, but in different order, so this counts it as different. That means we have to divide it by 3 factorial 6. That's why we have to divide by 6. So this is going to be choose 2 from 6. So that's 6 choose 2 times choose 2 from 4. So that's 4 choose 2. And then divide by 6. So this is just going to be, these are going to cancel. So we have 15. And then next, if we have 2 friends, then that is going to be, first of all, we can either have like this kind of hexagonal configuration, right, where each person is friends with the 2 person on their left and right. Then that's going to be 5 factorial over 2, because having friends in a hexagon like that, that's just the number to seat these 6 people in a round table. But then we have to divide by 2, since these 2, if they are swapped around, then it's just the same. That's why we have to divide by 2. And then next, we have to plus, and then 6 choose 3 over 2. And that's because we can have this kind of Star of David configuration, where these 3 people are friends, and these 3 people are friends. And then, if you look at this, it's just this and this. So we have just 2 triangles. That means we can just choose 3 people from the 6 to be friends, and then the other 3 will automatically be friends. But then we have to divide by 2, because choosing this first and then choosing that is just equal to choosing this first and then choosing this. So that's why we have to divide by 2. And this is going to give us, and that's going to give us 140 divided by 2. So this is 70. And then if we have 3 friends, we don't have to calculate this actually, because the number of possibilities for 3 friends is equal to the number of possibilities for 2 friends. This is possible because if we have 2 friends, but then let's just say that we tried to do the opposite of everything. We became friends with the people who we were not friends with, and we became not friends with the people who we were friends with. We just be friends with the friends that we were not friends with. That would give us 3 friends. So that means this and this has the same possibility. That means this is also 70. Same thing happens for 1 friend and 4 friends, and that means then this is just going to be the same here. So that's also going to be 15, right? And so now the answer is when we add all of that up. So 2 times 15 plus 70, that's going to be equal to 2 times 85, which is 170. So this is our answer. It's B. Number 20. Consider the polynomial px equals x to the 2 of k plus 2 to the kth power, which is just all this, right? The coefficient of x to the 2012th power is equal to 2 to the 8th power. What is a? Okay, so basically what this means is that for each term of x, like x to the 2012th power, each term of that is going to contribute either its x or its constant. So if we wanted something like x to the 5th power's coefficient, that means this and this would contribute their x, and everything else, like this one, that would contribute their constant. So x to the 5th, and x to the 8th power, that would give their constants all the way to 1024, and that's going to be the coefficient of x to the 5th power. And so now what we have to do is we have to figure out what 2012 is made of in terms of powers of 2. So if we do that, we see that 2012, this is equal to 1024 plus 512 plus 256 plus 128 plus 64 plus 16 plus 8 plus 4. That means we are missing 32, 2, and 1. So that means that these numbers, they contributed their constants like that. So that means those will be our coefficient. So our coefficient, that is going to be 32 times 2 times 1. That is 64. And 64 is 2 to the 6th power, so that is 6. That means A is 6. It's B. Number 21. Let A, B, and C be positive integers with A is greater than or equal to B is greater than or equal to C, such that this and this both holds true. What is A? Okay, so first of all, we just want to add those two together. And so if we do that, then we are going to get 2a squared plus 2b squared plus 2c squared minus 2ab minus 2bc minus 2ca. This is going to be equal to 14. And we can see that this is just equal to a squared minus 2ab plus b squared minus 2bc plus c squared minus 2ca plus a squared. And that's just a minus b squared because of that. And that will become plus b minus c squared plus c minus a squared. And so this is all going to be 14, which is just 1 plus 4 plus 9. And so that gives us that a minus b, this must be equal to 2, and a minus c, so this must be equal to 3, and this must be equal to 1. So this gives us that a is just a, and b is equal to a minus 2, and c is equal to a minus 3. It's because a is greater than or equal to c, a is the biggest, that's why c is a minus things. So if we put these into this equation, right, then we will get into here, then we will get a squared minus a minus 2 squared minus a minus 3 squared plus a times a minus 2 is going to equal 2011. So this gives us that a squared minus a squared plus 4a minus 4 minus a squared plus 6a minus 9 plus a squared minus 2a equals 2011. So canceling, we cancel this, we can cancel those two, and then we can finally get 8a equals 2024. This gives us a equals 2024 over 8, which equals 253. So that is our answer. It's E. Number 22. Distinct planes P1, P2 all the way to PK intersect the interior of a cube Q. Let S be the union of the faces of Q, and let P equal the union of J to J equals 1 up to P of PJ. The intersection of P and S consists of the union of all segments joining the midpoints of every pair of edges belonging to the same face of Q. What is the difference between the maximum minimum possible values of K? Okay, so like these kinds of terms, they are very confusing. And so let me tell you what these are. So this basically means that you take the union of every P where J is equal to 1 to K, right? So this is basically just P1 union P2 union P3 union P4 union all the way to PK, right? But then right here in this context, this basically means that S is just going to be all the faces of Q, and that's going to be all the planes that intersect this S, right? And what this is saying is that if we have the cube Q, so this is going to be our cube. If we have that, and we have like planes, K planes, then the intersection of the planes and the cube's faces, they are going to be all of the segments during the midpoints of every pair of edges belong to the same face of Q. And so all segments during the midpoints this much, that's going to be like this, right? So that's going to be like that, joining every midpoint for all the faces. So this will be repeated on the bottom face and the left face and the face on the back. So this is going to be on the bottom too, like this, right? And on here too, and on here too, and more on the back. And it's saying that these are the intersection of P and S. So it's basically saying that these are the intersection lines of the planes and faces. So now what we want to get is the values of K. Now we will look at the number of cases by the number of diagonals that the plane intersects. So first, if the plane goes through no diagonals, and by diagonals I mean like these diagonal lines like that, like this, that's what I mean by diagonals. And so, and the planes that don't go through those diagonals, we just have 3 of them. One will split this into right and left, one will split this into top and bottom, like that, and one will split this into forward and back, like that, right? So we have 3 of them, like that. And then after this, we need to go through at least one diagonal. And so let's say that we go through this diagonal. And then for all of this, then we are going to have 3 possible ways to proceed. One, we can go inward, one we can go straight down, and one we can go outward. And so let's do the inward first. If we go inward, that's going to be this line. So that plane would just come out like that. So that's going to just be cutting off a corner. So this has 8 because this is cutting off corners. And this goes through 3 diagonals. If we choose to go straight, then I will erase these blue marks. And if we choose to go straight, then we will go like this and then straight down like that. And then that will end in that one. So this gives us 2 diagonals, and that's just basically cutting off this edge. So that's cutting off this edge. So this much, that's cutting off this edge. So that's the number of edges. So straight down, that's the number of edges, so that's 12. And that has 2 diagonals. Lastly, when we're going outward from here, so when we're going outward like that, that means we will go like that, and then we will go around to the back, and then finish in that back. So to make this easier visualization, let's just say that we start here. Then we will go this way, that's just going outward, and then we'll come here, and then we'll end right there. So that is going to be that's going to be our plane, and that's going to go through 6 diagonals. And so outward, that is 6 diagonals, and we are going to have 4 of them, right? Because we have 24 diagonals in total. So we're gonna have 4. And now let's consider the maximum and minimum values. So first of all, the maximum values, that is when we just take every plane that we can get. So that's 3 plus 8 plus 12 plus 4, 8 plus 12 plus 4, that is just 27. So this is the maximum. And for our minimum, first we will just have to use this one, because that's just a given, and because that doesn't go through any of the diagonals. And then we have to choose planes from here that will cover all of the diagonals in the minimum way possible. And so that's just going to be this, because we have 6 diagonals on each, and this covers the whole thing. So that's just 4. So this is going to be 7 minimum. So our total value, that's going to be 27 minus 7, which is 20, and that's our answer. It's C. Number 23, let S be the square, one of whose diagonals has endpoints 0.1, 0.7, and minus 0.1, minus 0.7. A point V equals x, y is chosen uniformly at random over all pairs of real numbers x and y, such that x is between 0 and 2012, and y is between 0 and 2012. Let T of V be a translated copy of S centered at V. What is the probability that the square region determined by T of V contains exactly 2 points with integer coordinates in its interior? Okay, so what this is basically saying is that we have a square with endpoints that are 0.1, 0.7, and minus 0.1, 0.7, and that means the other diagonal that will have endpoints like that. So that will be our square. If we bring out our square, that will look something like this. So this is going to be our square. And we have this point V, where x and y are between 0 and 2012. So we're going to have this big 2012 by 2012 grid like that, and then up there we're going to select 1 point over which to center this on, right? To center that on, and then we want the probability that TV contains exactly 2 points with integer coordinates, so these are exactly 2 lattice points in its interior. So first of all, let's look at this square. This point is 0.1, 0.7, and this is minus 0.7, 0.1. And so that means that if we have lengths like that and that, then we will have, this length is going to be 0.1 to minus 0.7, so that's 0.8. And this length to that length is going to be 0.1 to 0.7, which is 0.6. So that gives us that this is a 3 to 4 to 5 triangle. That means this length is 1. That means this is just a unit square that's turned around. And so now we just want to deal with one grid of the unit square, because the probability for the whole 2012 by 2012 region can be broken down into just, we can look at only one unit square of these 2012 by 2012 like massive thing, because the probability for one unit square, that's just going to be equal to the probability for the whole thing. And so now, yeah, let's make this a little better, and that's going to look like this, right? So this is going to be our unit square, and same as this, it's going to also have length of 1, right? And so if we mark the center like that with the red dot, then we can get that over here, and we can move it around, but then the dot has to stay inside this green line, right? And so now focus on the red dot, because I am first going. And so if we say that this red point is the center of, then that will be V, and we will want this like V to be in such a position that this thing covers 2 lattice points, right? Either these 2 or that, or those 2 or these 2 or these 2, right? And so if we bring that out, then that will look something like this. This red dot is the midpoint right here, and now we want the probability for this to cover exactly 2 lattice points like that, right? Or like that, or like that, or like this. First, let's just focus on how can we cover just one lattice point, right? So let's just focus on this one. And for the region to contain only one lattice point, right? Let's try to move this around with it barely containing this lattice point like that. And so it's going to move like that, and then it's going to turn around like that, like that. And now keep your eyes on the red dot. See how it moves, and it's going to be like that, and like that, and like that, right? And so if we trace around where this red dot is going, we can see a shape that is very similar to this actual square, right? And so that's going to be something like this, like that, and that is going to be where, and that's going to be where this red dot can be for it to include exactly 1 point for it to include 1 lattice point. And so as long as this red dot is within that red square, then it's going to be possible for the black square to contain this lattice point, right? And the same goes for this lattice point over here too, because if we do the same thing like that, right, going like that, right, and barely containing the point, then we are also going to see the same thing as this happen. So that way we are going to get a boundary like this. So the black one's the boundary, and since each of these squares represents containing one lattice point, that means for it to contain both lattice points, for it to contain two lattice points, then it must be at its intersection. And so this is where the center must lie in order to contain both points. We now realize that since this distance is 1, that means this black square is just the red square translated by 1 to the right. So this is just 1. Let's do that in orange. So this is just going to be equal to 1. But then since we know that this is 1, and this is a 3 to 4 to 5 triangle, we also know that this is a similar, that's the same 3 to 4 to 5 triangle. So that means since this is 1, and this is 3 to 4 to 5, that means this length, that's going to be 0.6, and this length is going to be 0.8. So now we have the fact that that length is 0.2, and we know that this length is 0.4, and that is because this whole thing is 1, and this whole thing is 1, right? So it doesn't look like it, but this length is actually double of this length. So the area of overlap, this is going to be equal to 0.2 times 0.4. So this is 0.2 times 0.4, which is 0.08. That's the area of the whole blue region. But since we're only dealing with this unit square, then it should be just the region within that unit square. And so we see that this much is, that is just the bisector of this rectangle. So that just cuts the rectangle in half. That means this area, which is the area that we actually want, that's just half of the whole thing. So that means the area of the thing that's inside, this is going to be 0.08 divided by 2, which is 0.04. That means each of this is going to have 0.04 area. But then now we can have it contain both lattice points. We can have it here, or we can have it here, or here, or here, right? So that's 4 in total. So we have 4 of these. So that means we have 4 of these. So 4 times, and then each of these area, 0.04, this is going to be the answer, 0.16. And 0.16, this is equal to 16 over 100, or 4 over 25. So that means this is our answer, and it's C. Problem number 24. Let AK from K1 to 2011 be the sequence of real numbers defined by A1 equals 0.201, A2 equals 0.2011 to the A1 power, A3 equals this, and A4 equals that. And in general, AK is going to be this if K is odd, and this if K is even. Rearranging the numbers in the sequence, this in decreasing order produces a new sequence that we will call BK. What is the sum of all integers k such that AK equals BK? Okay, so first of all, let's try to arrange this in order and see what we get. So for us to be able to compare those numbers, we first have to get a sense of what happens when the base increases, what happens when the exponent increases, like that. And so let's just first see that this is all very similar to 0.2. So 0.2 to the x power, this is going to be equal to, that graph is going to look like this. Sorry, that graph is going to look something like this, with this being 1. And as x increases, then the value is going to get smaller. So this gives us that exponent increases. That means the value goes down. And this is true because this is between 0 and 1. And next we have these exponents, right? But then these exponents are also going to be between 0 and 1. And so we know that x to the 0.2 power, this is going to be equal to, the graph is going to look like this. And that's because this is between 0 and 1. Since all of these are going to be between 0 and 1, this gives us that as the base increases, then that means that the value increases, right? So as the base increases, the value increases. And so these two facts will be very important for us in figuring out the order of A1, A2, A3, and A4. Okay, so now let's start comparing A1, A2, A3, and A4. First of all, let's try A1 and A2. And A1 is 0.201, A2 is 0.2011, and this is 0.201 to the first power, and this is A1, so this is just 0.201 power. And we see that the base is bigger for A2, so then the base increased, and the exponent has decreased because A1 is like 0.2, and the exponent decreased. So since base increased, the value increases. since the exponent decreases, that means the value increases. This gives us that a2 is greater, so a1 is less than a2. And next, a2 versus a3 versus a3. This is going to give us that a2 is this and a3 is that. And we see that the base got smaller. The exponent, this is a1 versus a2, and we did say that a1 is less than a2. That means that the exponent got bigger. So the base got lower, that means the value got lower, and the exponent got larger, that means the value also got lower. So this means that a2 is less than a3. Sorry, this means that a3 is less than a2. So a2 is greater than a3. Next, a1 versus a3. This is going to give us that a1 is 0.201 and this is 0.20101, so that means the base went up. And the exponent, this went from 1 to a2, so it decreased. Exponent decreased. This gives us that a1 is less than a3. a2 versus a4. This is going to give us that, these two, right? So the base went down, the base decreased. The base went down, and the exponent went up because it went from a1 to a3, and we just saw that a1 is less than a3. So this gives us that a3 is less than a4. And lastly, we'll compare a3 versus a4. So this is going to give us that the base is going to increase, the exponent is going to decrease, because we see a3 and a4 like that. This will give us that a3, so that should have been a2. So this will give us that a3 is less than a4. And so now that we have all these facts, we can now see that the order is a1 is the least, and then a3, and then a4, and then a2. Then now, if we look at the general thing, we can see that if k is odd, write that down here, a1, a3, a4, a2. And so in general, if k is odd, then that means that always the base is going to be greater and the exponent is going to be less in the next one. That means it's always going to increasing like that, right? So just look at a1 and a3. We just said that always the base is going to be greater and the exponent is less. That means a1 is less than a3. And that holds true for all k is odd. And for k is even, it's something similar. Always the base is going to be lower and the exponent is going to be higher, right? And so that means it's in decreasing order. So we have that, and we have one more. Always k, when it's odd, this is going to be less than when k is even. So always k odd is going to be less than when k is even. And so now we can make this bk sequence. So if we do that, then we are going to get b1, b2, b3, b4, all the way to b2009, b2010, b2011. This is going to start with a2, right? Because a2 is the biggest, since even is always bigger and it's decreasing. So a2 is always going to be the biggest, and then a4, and then a6, and then a8, all of the even numbers, until we reach the midpoint. And then now we're going to start odd with the highest odd number. So somewhere in the middle, a2011, and then a2009, and then all the way up to b2009, that is going to be a5, and then this is a3, and then b2011, that will be an a1, and then it's going to end. And so we see that it changes from even to odd in the middle, and we also see that this ak equals bk, and this cannot be not in the even part, because always a will be outpacing the b's. So since a will always outpace the b's, then it's not going to be in the even. So that means it's between half, which is 1006, this is half, and the end, so 2011, which is the end. So the only number that's between 1006 and 2011 in the answer choices, it is C, right? That's 1341. That's why the answer is C. Last problem, number 25. Let fx equal the absolute value of 2 times the fractional part of x minus 1, where the fractional part of x is the fractional part of x, and the number n is the smallest positive integer such that the equation n of x equals to x has at least 2012 real solutions. What is n? Okay, so we all know what the fractional part of n is, right? It's like literally the part of n that's a fraction. And so our only solution here is to graph everything. First of all, we can see that here, this much is going to be a positive number because fx is the absolute value. That means this is positive, and since n is the smallest positive number, so this is also positive, that means we can only want to consider when x is positive. This means x is positive. And now let's get into the graphing. First, let's try f of x, right, because this is where it all starts. The graph of f of x, this is going to be 2 fractional part of x, and then minus 1. And then it's going to be absolute valued. So this is going to have a maximum of 1. So if we have the graph, right, then, so if we start with this is equal to 0, then that's going to give us the absolute value of -1, so that will start us at 1. When x is equal to 1/2, then that will give us 0. So that's going to give us 0, so it's going to be like that. And then when x is 1 again, then it's going to be the absolute value of 1 like that. Note that this is the fractional part, and so this is 1 because when x is an integer, then this becomes 0. That's why it's just the absolute value of -1, which is 1. So since this is the fractional part, that means it is periodic by 1. So this is periodic and repeats every 1. And so that means since this number, that point is 1, and it's 2 and 3, that means this shape is just going to repeat for every time. So that's going to repeat like that, and so on, like this, right? Now we have x of x, right? We have x of x. Let's try to graph that one. X of x. This is just fx, but with an x tacked onto it. And so since we are multiplying x, that means values can get larger. If we draw that, we have 1, 2, 3, and 1, 2, 3, like that. First of all, let's try to go from 0 to 1/2. So from 0 to 1/2, what we're going to have is, so it's x times f of x, and when it's half, it's going to be 0. So 0 times anything is 0, so that's 0. And 0 is just 0, so that's 0 times 1, that's still going to be 0. And in between these, we're going to have like this small bump, and then we have to notice that this bump doesn't really reach the half point. So this doesn't not reach half point, since at the quarter point, since the x is always going to be between 0.5, and this is always going to be between 0 and 1, and the fx is between 0 and 1. And so that means this is never going to actually be 1/2. And so now let's head on to the other parts. Next is when it reaches 1, right? When it's 1, then it's going to be 1 times 1, so it's going to be 1, so it's going to go here, and let's do it like that. But then when it's 1.5 again, it drops to 0, right? So it's going to go like that. And when it's 2, it's 1 times 2, so that goes up to 2, so that goes up to right here. So that's going to go up like that. And then at 2.5, it's going to come back down again. These are not actually like straight lines, they're actually more curves, but then they're not really important, so we can just think that they are straight lines and then just do our problem. When it's 3, then it's going to be 3 times 1, so that's going to go up to 3. So that's a big bump. And that's going to come down like that when we have 3.5. And so on, it's going to get larger and larger. And that is it for our x of x graph. And now we have to do f of that. So we have to put f on this one. And so if we do that, now we have f of x, f, so this maximum is always 1, so this maximum is always going to be 1, so let's just draw this like that. This is going to be 1, this is 1, 2, and 3, like that, right? First of all, we have to notice that since this is f of x, that means this is going to have the similar qualities as this thing, but it's going to kind of look different. And for here, when x f of x is an integer, that means this is going to be 0, so that's going to be 1. When x f of x is like 1/2, 1 and 1/2, like that. So if that happens, then that means that this is going to be 1/2. So the fractional part of x is 1/2. That means the whole thing is 0. That means it's going to be 0. So keeping these facts in mind, we will try to draw this. First of all, this part, the little bump. So we said that this part, it never really rises to 0. So it never really reaches 1/2. And so that means it doesn't really go to 0. So it's going to go like that, and then come back to 1. And it's going to come back to 1 because right here, that's when x of x is an integer. It's 0. And so I'll just, mark in orange all the parts where it's x of x is an integer, like that. And so that is when it's going to be an integer, right? So we have our graph like that. So we have 0 at a half and then at 1, right? So we have our orange at a 1, 2. Yeah, and actually I'll put these values on right here also, right? So for 1, we actually have one more value here. And then between 1 and half, we have nothing. So we have 1 half. And then at 2, we have something. And between that, we have one more. And we have one more at 2.5, so we have 2.5, and then we have one more. And then for 3, we have one right there. And between that, we're going to have two of those, right? So if we have 3, and then we're going to have two of those. And then if we extend this a little bit more, if we extend this a little bit more, then we're going to have until 3.5, like that. And then those two are going to be in the middle, so let's put it like those. And so now we can proceed. Now let's look at the part where it's from Now let's look at the part when it's from half to 1. So from 1/2 to 1, that's going to be this part. But then we can see that through there we are going to cross the point where it is 1/2. So, sorry, 1/2. And when x of fx is 1/2, then it's going to be 0. So it's going to be touching 0. So it's going to look something like this. Same thing when it comes down, right? Because this is also going to be 0. So that's also going to be here. And so that is also going to be like that, right? Now for this one, we are going to have those 1/2 points right here, 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 and here, right? So in between every orange point, we are going to have one blue point. That's when it's all 0. So that will make it like this, 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 and this. And then lastly, it's going to have 6 of these right there. And so between every orange, there's going to be a blue, like that, like that, like that, and like that, like that, and like that, right? And so now if we draw it, it's going to look something like this, 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 and this, this, right? So right now it looks really messy, but if you kind of like cut these up, then you can actually see a pattern emerging. Right here we have two touching 0 points, 2, and then here we have 4, and then here we have 6, like that, right? So we do see a pattern actually. And now, since this is the graph of f of x, and we don't want to multiply into that, we can just say that f of x is equal to x over n. So this is equal to x over n. So if we just draw x over n here, then it's going to start from 0, 0, and it's going to go all the way until this is n, right? So this is x over n, and then right now, dropping down, that's going to be n, right? So that's going to be n. And looking at the graph, we see that there are 2 intersections for every for every V shape, right? So we have 2 right here, 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 like that, right? Now, counting by each gap of 1, we see that we have 2 intersections here, and we have 6 here. We have 6 here, and then from 2 to 3, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 intersections, and 14 intersections, and so on, like that. And so if we look at these numbers, it's going to be 2, 6, 10, 14, and so on. But we have to add all of those, right? And this is just equal to 2 times 1, 3, 5, 7, 9, all the way like that. And we see that this is just the sum of all numbers, which is just n squared, right? So this is 2n squared. And now we see that 2n squared, this is the number of real solutions, right? Because that's the intersections, that's the number of real solutions of this. But then this has to have at least 2012 real solutions. And so what it's asking us is for 2n squared to be greater than or equal to 2012. So for that to happen, n squared has to be greater than or equal to 1006. And so since 32 squared is 1024, that is the smallest value that is greater than or equal to 1006, and 31 squared won't do it. And so this gives us that n equals 32, and that's our answer, so it's C. This was it for the AMC 12A from the year 2012, and thank you for watching.